This is section 1.4, continuity and one-sided limits. So, starting with continuity, a function f is continuous at c, or point C, if the following three conditions are met. F of c is defined, so there's not a discontinuity. The limit as x approaches c of f of x exists, and that the limit and the function value are the same. So we have three types of discontinuity that we talk about. Removable discontinuity is where it's a hole. You could have a point above or below the hole, but as long as there's a hole there, that's removable. It would otherwise be continuous without that. We have a jump discontinuity where your function is going and then it stops, jumps up or down, and then it continues from there. And then an infinite discontinuity, which is where we would have a vertical asymptote. So find the limit as x approaches 2 from the left and the limit as x approaches 2 from the right of f of x, algebraically and graphically. So let's start with algebraically. So when we have this little negative or a little positive right there, negative means coming in from the left, positive means coming in from the right. So let's look at algebraically how we would find this. So if we look from the left, we're going to use the first part of the piecewise function. If we're coming from the right, we're going to use the second piece. So let's start with the limit as x approaches 2 from the negative of x plus 1. So when we're evaluating limits algebraically, remember we can just use direct substitution for a polynomial. So I'm going to plug in 2. 2 plus 1 is 3. From the right, we're going to use the other piece. So x approaches 2 from the right of x squared minus 4. Again, we can use direct substitution. 2 squared is 4, minus 4 is 0. Notice that the left hand and the right hand limit are not the same. So that means the limit is, the actual limit doesn't exist. So let's try graphing it. I'm going to draw a really rough sketch of a graph. So x plus 1 for x is less than 2. So here's 2. Make sure that it's an open circle because we don't have the equal to. So 2 would go with, oops. I'm just going to make a graph here really quick. All right. So 2, 3 is an open circle. And we're going to go like, oof, man. We're going to go like this. Okay, and it's going to go on forever and ever in that direction. The other one, x squared minus 4. 1, 2, 3, 4. So if we plug in a 2, we'd get 0. If we plug in a 3, we'd get 5. 1, 2, 3, 4, 5. And it would look something like this. So from a graph, we would just look and say, hey, coming in from the left-hand side, we're coming toward 3. Coming in from the right-hand side, we're coming in towards 0. Notice we have a jump discontinuity. So relating two-sided limits and one-sided limits, the two-sided limit exists if and only if both one-sided limits are